Very good morning to you, and welcome to another Sante webinar. Just going to wait for a couple of people to join us, as normally a couple of minutes before we get up to the total live viewing. This is being recorded, as it always is, so if you didn't make it today and you're watching this later on, then welcome to you as well. First thing I'm just going to do is introduce myself while we're waiting for those people. My name is at the bottom there. It is Andy Camsell. I work as a technical advisor, I suppose, in a consultancy capacity with Sonte. So my role, as my day job, is working within the BEMS industry. I'm a partner in a systems integrator, but get very much hands-on with doing the work. We're a very small company, and so in that capacity, having a close relationship with Sonte, it's a really good symbiotic relationship where I get to test and play with their stuff, and I get to feed back industry information to them. So we work very much as a partnership, even though I don't directly work for Sonte. So that's me. That's what I do. Those of you who've seen these webinars before will know I've been doing this for a long time now. I think I've been in the industry nearly 40 years, been doing controls for just over 30 of those. So I've been doing BEMS for quite some time. So just going to jump into the slides now. Oh, everything's working. That's always a good start, isn't it? Just tell you what we're going to be talking about today. This is a seminar about using smart sensing technology, with a particular focus on healthcare environments, as obviously the name suggests. It's a really good application for smart sensing technology. So we're going to look at the challenges that we get with healthcare retrofit projects. We're also going to look at what smart sensors are. I'm guessing many of you will already know, but we often get people on these webinars who have sort of joined out of curiosity. So just run through what those smart sensors are, looking at how they communicate and integrate with the existing BEMS, how we can use that information to get actionable data. And that's really what we're interested in here, particularly, if you're working in a healthcare environment and medical environment. Is the data and analytics. How can we get that useful information? Going to look at some example retrofit scenarios. Everything that you will do out on site is going to be application specific. So these are examples of how smart sensing technology might be able to benefit you. Going to look at the benefits of using smart sensing technology, and again with just a little sort of focus on smart sensing rather than using traditional sensing technology, and then of course the future outlook. Spoiler alert, there's going to be AI in that bit. There always is these days. So these are the things we're going to talk about. I'm going to dive in with the reasons for retrofitting to start with. So obviously, here in the UK, we're very focused on the NHS, National Health Service. There are private healthcare facilities as well, but predominantly we're looking at NHS facilities within the UK. With the NHS, there is it's a huge organisation. It's obviously publicly funded, and so there's a huge focus on sustainability and also on the net zero targets which exist, as well as saving money and saving energy, which of course any public body and anyone would want to save money, but public bodies have an obligation to save public money. So there's a lot of reasons that you would want to get the best value out of your buildings, out of your estate, and by running your plant effectively and using multiple sensing values coming into your BEMS, you are going to be able to drive algorithms and analyze data more efficiently. However, there are particular challenges, as we'll see in the next slide, with retrofit activities in a hospital. A lot of hospitals, particularly again here in the UK, have ageing estates. Anyone who's been in a hospital will know that the buildings are not always brand new. We do have a lot of new hospitals, but there is a lot of hospitals which have been around for a long time. We still have Victorian buildings here. Those, again, can present challenges, but of course we need to understand how those buildings are functioning. And so using this smart sensing technology, we can get a feel for how our estates are performing. And as the next bullet point suggests, in terms of energy efficiency and operational performance, those are the key factors that we really want to assess when we're looking at any environment, but particularly in healthcare. And we also need to think about compliance and environmental monitoring pressures. These are pressures on the system to perform. When you're working in hospitals, they are probably the most complex estates that you will likely to encounter, or you are likely to encounter, only from the point of view that they have lots of different functions within a hospital. If you're working in an office block, it's an office block. If you're working in a laboratory environment or school environment, it does one thing. Hospitals tend to have a mix of all of those things. Hospitals, we tend to focus on the medical side of it, and rightly so. But there are administrative areas to hospitals as well. We need to consider those, and we have different control algorithms, different strategies for those. We also have areas which are open to the public but might not necessarily be medical facilities. So you've got your waiting rooms as well. And additionally, you'll have quiet areas. They have areas set aside in hospitals for, worship rooms, things like that. So there's a lot of scope within a hospital. You also have in hospitals other facilities as well, laundries, kitchens, all these things inside a hospital building. So there's a lot of stuff going on in a building, and that environmental monitoring is key to firstly saving energy, but ultimately actually saving lives. There is a thing with hospitals, if you're ever doing any sort of medical stuff, HTMs, which I believe the HTM spec stands for Hospital Theatre Management, but it is basically an NHS specification which tells you how that building needs to control all the pressure regimes. For example, if you have an operating theatre, it has to be under a positive pressure, so that if someone opens a door to the operating theatre, all of the stuff comes out. You don't get nasties coming in, which could cause an infection. So there's a lot of things that go into making up a hospital. If you've got an old hospital and you need to retrofit it, then we're going to see how smart sensing technology is going to really benefit you in that respect. When we are looking at the challenges that we have in a hospital environment, over and above what we tend to think of as the normal challenges elsewhere, the particular one that comes to mind is a live environment. People don't stop needing A&E at 10 o'clock at night. In fact, they usually tend to need it more at 10 o'clock at night. But, hospitals are 24/7 environments, so it can be really, really challenging to actually find a time when you can perform any retrofit activities. Now, of course, if you've got, taking A&E as an example, 2 operating theatres for emergencies, and you can find your quiet time, you shut one down, but you still want to get it up and running as quickly as possible. So we need to think about those live environments, the speed at which we need to add this functionality in so that we can control the space better, we can monitor the space better, and get it up and running really, really quickly as well. As I already mentioned, infection control is a big issue in hospitals for very obvious reasons. There's a lot of things come into this. I've mentioned the pressure regimes that we have in operating theatres, but we have other things as well. I'm sure many of you are familiar with, in the 90s, there were issues with Legionella bacteria in cooling towers. And what was happening was the cooling towers had excessive Legionella. It was being drawn into the ventilation system. So we have to think about all those issues as well. Legionella bacteria doesn't immediately cause people to, it's not fatal in every case, but it does cause ill health. If you've got a lot of people who are already ill, then you don't want to be subjecting them to those flu-like symptoms, because there's more likelihood that it could be fatal. So infection control in different areas is really important. Monitoring is very important. Redundancy and resilience. So redundancy is where we have multiple systems controlling a single or monitoring, controlling a single space. It's actually something which is not hugely common in hospitals. Resilience needs to be. We need to think about resilience as best we can. But a cash-strapped hospital, sorry, I put the wrong teeth in this morning. The cash-strapped hospital is going to be problematic because, of course, you can't have 2 air handling handling units for your operating theatre, each replicating the other in case one falls down, without some considerable expense. It may be appropriate, but it's not a common thing, particularly where we've got public money there. So we need to consider these items, but resilience is more important, or I'd say it's more focus on resilience than redundancy. So getting good quality components is really important. Redundancy can come into it. We're going to look at LoRaWAN and how we might be able to deploy wireless technology here. If you are using wireless technology, getting redundancy into your sensing network is actually really, really easy. Clinical and non-clinical systems, we have different areas of hospitals, so that can be a particular challenge. What type of retrofit activity do we need to occur in each of these areas? And then something which is nothing to do with the technical side of it at all is the complex stakeholder environment. I've recently been working in a hospital, and the stakeholder environment, I can assure you, is very complex. Everybody has an opinion. And rightly so. You have got hospital management. They are very focused on the financial side of it. You've got medical teams. They are very focused on the functionality to ensure that everything is doing what it's supposed to. It's controlling properly. You also have an estates department. They need to maintain the system. So there's lots of different, lots of different departments, lots of different stakeholders in this, who all have an opinion on how that space should perform. And so when we are retrofitting these particular areas, this is a particular challenge, which it says unique to healthcare. It's probably not unique, but it's certainly common in a healthcare environment. So the next question on everybody's lips, apart from people who already know, what are smart sensors? Smart sensors, it's a bit of a thing. We call them smart sensors, but really it's about how we use technology, in a smart way. Traditional sensors have a single function, and they connect directly to a BEMS, typically to a controller. Because they have a single function, they have one purpose, and they need all of the intelligence, if you like, to be in the controller. So when we talk about smart sensors, we're talking about sensors which will communicate with a BEMS controller or with another system via a bus technology. So it will send digital signals. Now that gives us, this digital bus communication gives us the benefit of having lossless signals to start with. When you have a wire, it is subject to voltage drop. So if you're looking to measure temperature and you're looking for 0 to 10 volts, the longer that wire is, the more voltage drop there is. You calibrate it, but there is an impact on the actual installation itself. Using smart sensors, they use this digital bus communication, so they send the value. They also can be set up to acknowledge the receipt of those values, so we can have resilience in the system, but we can also have lossless systems. And this one up here, should probably put these in a different order, but this multi-sensing technology. This is why smart sensors have become so very popular. You can have multiple variables measured by one sensor. It's very typical to have temperature, humidity, and CO2 in a single sensor housing. So 3 variables, but rather than needing 3 inputs on your BEMS controller, which these days someone will almost certainly try and stiff you for 3 licenses coming in, then you will have 3 parameters. Now, I'm aware of, obviously, in a BEMS, you now have to pay for virtual points as well. But there are systems out there where you could use bus technology and minimize the amount of I/O you need without additional licensing costs. There's a few and far between, but they are still out there. So we can have these multiple variables in one sensor housing. Aside from the licensing issue that we face in our industry, there is, of course, the benefit there of just having one box on the wall to sense everything. There is the ability as well with smart sensors to have them either wired or wireless. So we're going to look at both of those technologies here and the benefits and the drawbacks of each one. In terms of a wired technology, you would typically have an RS485 network, which daisy chains, so it visits each sensor in turn. The modern way of doing wireless technology, which I don't think there's any other way these days, is using LoRaWAN, long-range wide area networks. LoRaWAN is particularly useful useful over and above wired topologies, in as much as you don't need the wires, fairly obviously, but you with a LoRaWAN network, there's no potential for a break in the cable. If you've got a smart sensor which is visiting, a cable visiting each sensor, one cable break and you lose a load of sensors. It shouldn't happen, if you've buried your cables properly, but there is that potential. Whereas with LoRaWAN, obviously the only thing that would stop that, batteries going dead, etc. But it's very easy to build resilience and redundancy into LoRaWAN networks. So looking at the communications and integration of these smart sensing technologies, when we are using smart sensors, we will typically need to ingest that data into a BEMS. Now, there's sort of moves away from this. Sure, everyone's sort of very familiar now with the term IoT, the Internet of Things. I'll talk about that in a moment. But looking about getting this information into a BEMS, what we need is a robust and well-established open protocol so that we can choose sensors that will work with a BEMS, and if we retrofit our BEMS, then we can at some point ingest that data into a new system. Or we might be changing the system. You might have a BEMS which is talking to a bunch of smart sensors, and then you decide we're going to aggregate this data. We're going to bring this into a JACE, a Tritium device. And we're going to use that data in a different way. So choosing an open protocol is really important. So we need to choose sensors which will support those open protocols. There's a number out there. If you're wiring them, then BACnet and Modbus are your two main options. If you are using wireless sensors, then LoRaWAN and NOcean are the two big players in this. LoRaWAN, I would say, is some way ahead of NOcean in terms of popularity. But NOcean sensors are particularly useful because they are self-powered sensors. You have kinetic switches and solar-powered sensors, things like that. So they don't have the same range as LoRaWAN, but they do have the benefit of you never need to change the batteries in NOcean sensors. But using these open technologies rather than a closed protocol means that this smart sensing technology is going to be more adaptable for the future. And if we're looking at retrofitting a healthcare facility, then of course we've already considered the age of that building. Let's look to the future as well. The pros and cons of wired and wireless solutions. Wired solutions, as I say, if you have a smart sensing solution where you've got an RS485 network which is linking a bunch of sensors together and you get a cut in that cable, then you will lose everything beyond that cut in that cable, and there's nothing you can do about that. So that's really the only drawback of using a bus topology wired network. With wireless solutions, obviously we have the issue where the signal can become attenuated, the signal can become blocked if someone builds a big wall. It's actually not a massive problem with LoRaWAN. LoRaWAN it's dark magic, I tell you. But it is a possibility. But it's very easy to build redundancy into a LoRaWAN system because you can put two sensors in a space very, very easily. You don't need any additional wiring for that. One thing with wireless sensors is if you're not using NOcean sensors, if you're using LoRaWAN sensors, they have batteries in them. And of course, batteries will deplete over time. Now, again, with LoRaWAN, as I say, dark magic, it has an extraordinary battery life. You can get a temperature sensor where the batteries will last for 10 years. But they still need replacing. It's led to wireless technologies getting a bit of a bad rap. It's because in 10 years' time someone will forget to change the batteries. Well, if the whole building is not sensing, I think that will probably focus their mind. But it's not a great argument. There are benefits to using wired and benefits to using wireless, and you only need to look at our traditional networks for that, a telephone network, for example. If you don't think that wireless is of any use at all, then give up your mobile phone. You probably won't, will you? There's cases for both. If we can get wires in really easily, it's probably best to use a wired technology. If we can't, then LoRaWAN can give us some extra benefits. I'm going to look at LoRaWAN again because LoRaWAN is actually an IoT technology. So there's actually another benefit for using a wireless technology, which is its integration with wider systems, and that is the IoT cloud integration. If you are using a wired technology and you're using BACnet or Modbus, you are going to need some kind of integration device to turn that information into probably MQTT packets, message queuing, transport and telemetry packets, or some other, HTTP API, something like that, to communicate to a cloud system. Whereas if you are using LoRaWAN, it is out of the box designed for IoT. We actually, when we use LoRaWAN within BEMS, we scrub the online, the IoT part of it, and we try and make it work as an on-premise solution, which it does very, very well. But it's very easy to get it into the cloud because it was designed to have a gateway and be propagated onto the internet. We need to be able to interface easily with our BEMS or directly with our gateway, whatever it is. So when we're choosing a technology, we need to think about ensuring that we have a technology which is nothing is 100% future proof, but something which is tried and tested. And like I say, if we're using these protocols, RS485 networks have been around for decades and decades. LoRaWAN, there are no wires, so as long as we have gateways for LoRaWAN, that's going to continue to work. We can easily interface with our building energy management system. We can interface with a gateway. We can make use of that data. If we are using, data aggregators, so we're getting data into a system, again, like I say, it's something like a JACE, a controller, Tritium type controller running the Niagara framework, then we can often use existing hospital infrastructure to communicate that data around the system. IT in hospitals has been important for other reasons for a very long time. If we're bringing a BEMS onto that IT system, then all of the campus-wide IT will likely be in place. You'll have fiber optic running between structure. It's going to save a lot of time on your installation. When we're considering retrofitting, there's a number of things that we want to consider. And the thing that really isn't here and should be at the top of this list is, why are we doing this to start with? And of course, there's a number of reasons. It is likely going to be that we want to have better control of our system, and better control leads to better energy efficiency. If we have better energy efficiency, then our building is more sustainable, and we also are compliant with the various requirements of Part L of building regulations. But beyond that, looking at maybe BREEAM compliance, something like that. Building Research Establishment Energy Assessment Method, where we're minimizing energy use. So we need to understand what that is. And then we need to look at what we need to achieve. So surveying the space and looking at the requirements is really important as a part of the start of any process. You'd be surprised how often that doesn't happen, but just for completeness, here it is. Go and have a look before you do anything. You need to understand what you need. Now, I always say, and it's very true, you can't have too many sensors in a space. You can always make use of that information somehow, even if it's just, you've got two sensors next to each other and they're providing redundancy. So you can't have too many sensors, but there are cost implications to doing that. So you need to understand what your objectives are and where you need to put that sensing technology. Look at the sensor coverage. If you are looking at, for example, a wing of a hospital with you've got recovery rooms, you've got assessment rooms, theatres, toilets, waiting areas, all those kind of things. Look at all those spaces. What do you need? How many sensors do you need to cover that? And what parameters do you need to measure in those spaces as well? Some might be already measured. If you've got operating theatres, it's really unlikely they're not going to have a pressure regime in place. So those are in place, but maybe you need some supplementary monitoring. Maybe there's an anaesthetic area which doesn't have its own temperature sensing space, or a prep area. Look at what those requirements are. We have to think about the phasing of the installation for a medical environment. If it is a day clinic where it's open 5 days a week, then it's going to be easy to plan because you go in at the weekend. But if this is, as I used the example before, accident and emergency, that it doesn't stop. It's a 24/7 process. So we need to think about how we are going to commission, calibrate, and validate that environment, make it work with minimum disruption. And this is where our smart sensing technology really comes into its own, because when we are installing these smart sensors, particularly with LoRaWAN, you literally put them on the wall. Now, best example can give you is we did a school a couple of years back, and you weren't allowed to drill anything onto the school, and we literally took LoRaWAN sensors and velcroed them onto the wall. It took minutes to install the sensors. Probably not the most attractive or robust installation ever, but we couldn't drill into the walls. It was a passive house building. So, installation can be really, really quick, and where time is literally about lives here, the minimal amount of shutdown time is obviously critical to this. We also got to think as well about how we hand this over to the hospital, usually the estates department. You don't really need much training on sensors. Those tend to be a very sort of generic type of device that people will understand. But if we're putting in a wireless technology where previously they've only had wired sensors on their estates, then of course we need to give some consideration to how we, the battery replacement, how you go about changing those batteries. And make sure that when it's handed over, everyone understands what the new parameters are, what the new operational parameters are. In terms of looking at the sensors, we would normally rely on our BEMS, on head ends, something like that, to bring those values in. And there's no difference looking at a smart sensor to looking at a traditional sensor, but like I say, things like batteries, we need to make sure staff are aware of those. If we've got a bus topology, then they need to be aware that, look, if you've got these 5 rooms offline, then we need to start looking at the cable. What happened? Did someone been up in the ceiling? Has something happened to cause this issue? Once the information is there, the benefits of smart sensors can really be realized. Data visualization and reporting tools are everywhere now. Everybody loves a dashboard. KPIs, key performance indicators. In healthcare, you have got a building, the trust has a building, NHS, it's NHS England at the moment, but there will be a body overseeing the hospital trust, and then the trust will be looking to the estates department. All of those bodies will have key performance indicators in place, metrics, so that they can measure the performance of the building. Now, a lot of the focus is obviously going to be on energy efficiency, because in terms of the running the estate, we want to minimize the cost, but it's not the only KPI that is important in a hospital. You need to maintain the correct environment. What nonsense would it be? It's like, I'm sorry that yes, your operation was a hideous failure, but we had to turn the air conditioning off because it was getting a bit pricey. It's not the only metric we need. We need to maintain the environment, the pressure regimes, the temperature, the humidity in the spaces. Things like operating theatres, anaesthetic gases are actually quite combustible, and so you have to manage the humidity in operating theatres. If humidity gets very low, then static discharge can be a problem. Now, there's all kinds of things that they do to isolate power supplies in operating theatres to stop that happening. Don't want to worry anyone. There's a lot of things in place to stop static discharge, but maintaining a level of relative humidity or ensuring that there is a level of relative humidity is an important factor as part of that process. So there's lots of KPIs and compliance indicators. And once we have our sensing technology in place, we can ensure that those are being met. The estates department themselves, once they've got extra sensors in, if we're putting these in plant areas or we're putting these in spaces, we can get more actionable data, plant failure alarms. Instead of just, the whole thing's gone off, we can nail it down. We can see granular information about our space. And of course, with predictive maintenance, if we can see trends occurring where performance is dropping off, then we know that we need to go and perform a maintenance task on there. The integration into BEMS and graphical interfaces, I think, is barely worthy of mention. It's so normal now that we would do this, that I think it's probably just worth noting that when you have smart sensing technology, although the technology that's out in the field has given you huge benefits in terms of that retrofit because it's reduced your installation costs, what you get on the BEMS head end is the same. So it's a very familiar graphical environment for people to use. The potential for retrofit within healthcare is huge. There are lots of different spaces. Patient recovery areas, if you have a recovery area, they tend to be quite large spaces. Years gone by, we would have called them wards. They are recovery areas now. But those spaces are often segregated. You still have male and female segregation. It may be that you've only got one sensor and there's a curtain across. You need two. So using things like LoRaWAN sensors, going to a backnet gateway could bring that data in. You could get better control over those spaces, better monitoring. You may find out, look, it's really cold at one end of the room and really warm at the other. Maybe help with redistributing the air or the temperature control in that space. If you have an energy centre in a hospital, so where we think about an energy centre, rather than every single building in the hospital generating its own heat, you will tend to have a centralised heating and cooling system, which will pass hot cold water around the estate. That needs to be monitored, and it's very easy to monitor it in the energy centre itself. But once it leaves the energy centre, what are the losses? If you've got LTHW, which is leaving, so you've got a massive heat pump section, which is generating heat. What's it doing when it gets to the end of line or during its transport path? So we can add supplementary monitoring into our systems using smart technology very easily to get a better idea of how our systems are performing. Of course, operating theatre compliance monitoring, as I've said, pressure regimes are quite important, but also you may have sub areas of an operating theatre. It's quite common to have the operating theatre itself, and then you have a prep area, then you have an anaesthetic area, probably some kind of storage off to the side as well, which is dedicated to that operating theatre. If it's a modern operating theatre, all of those will be accommodated for in the in the initial build. But if you've got an older style, it may be that there's only one sensor. There was only the need for one sensor in the operating theatre before, and now we can add those supplementary spaces in there as well and ensure that everything is compliant. And also condition monitoring in plant areas as well. We can look at monitoring how plant is performing. And like I say, if we see degradation over time, we can perform maintenance tasks on that. The benefits of retrofitting, particularly with using smart sensors, the big ticket item is actually not on this list. The big ticket item is the reduced installation cost. If you needed to retrofit a space, let's say, you've got a wing of a hospital, you've got 20 rooms of various types to monitor. If you had to run 20 cables from those spaces through an old Victorian building, which at some point will have had internal walls built, which will almost certainly have asbestos in them. It is hugely problematic to do this. So we've got to run a lot of cables. We've got to run them through old buildings, which are very difficult to access. And we're likely, as I say, going to have issues coming up against asbestos there. Asbestos only a danger when it's disturbed. This would disturb it. So the installation or the reduction in installation costs by being able to use some additional IT technology or using a wireless solution is the big benefit here. But ultimately that leads to a better system. That can lead to improved patient comfort and ultimately safety. Energy reductions. Everybody's about the energy reductions, but it is very important. Hospitals use phenomenal amounts of energy, and so anything we can do to reduce that bill is going to be very significant. You only need to look at if you've got an energy bill that is £500,000 and you save 1%, it is a significant saving. Hopefully your savings will be much bigger than that, but that's a significant saving on your energy bill. And I would imagine many hospitals, the £500,000 is a low energy bill. So energy reduction and reducing the cost of energy is important, as well as those carbon emissions for compliance reasons. We can optimize our plant. The more sensing information we've got, the more we can tweak our plant and make sure that it's working as it's supposed to. If we've got a single sensor working in a space in the hospital, we are beholden to the information that we're getting from that single sensor. We change that up. We get 5 sensors in the space, so we can say, actually, it's controlling this space, but we're seeing that it's overheating these spaces. So maybe we can back this off. Maybe we could, change the control regime in the space, so we can optimize our plant and make sure it's working exactly as it should do. Our compliance information and our reporting and our maintenance can now be data driven, as it should be, but it's always been quite difficult to do. You get a lot of hospitals. I can remember back in the day. Oh yes, where we used to put in a lot of safe control systems, SCS Climo equipment. It was of its time. It was great, still is. I mean, as a discrete control system, I don't know many that really surpass the old Climo stuff, but it was limited in its functionality because it's all based on hardware, not software. And so when you put in a BEMS and you retrofit it initially, you still got that one sensor that was going back to your discrete control system. By retrofitting with additional sensors using this smart topology or wireless sensors, we can now get extra values coming back in. And so our compliance can be driven by real data rather than assumed data. It also puts the foundations in place for a smart hospital transformation. I'm going to talk about IOMT in a moment, the Internet of Medical Things. Another name that nobody could really be asked to think up of a good one. It's our Internet of Medical Things. But the idea is that there's an interaction between the building, the patient. Everything happens in a more automated fashion. So as I say, we'll look at that in a couple of slides' time. ROI, return on investment. I did remember to put in this slide, ROI is not the only metric for medical applications. For so many things it is. We have to have a return on investment. But here it's a bit of a nonsense. Yes, you do want those sensors or this new technology to pay for itself over time, but that may not be the only benefit that you're getting from this. We need to also think about how that space is working and whether it is compliant. Safety is a really important metric for fairly obvious reasons. And as I say, the nonsense of, we had to shut all the plant down because it was costing too much. Of course, that's not going to happen. So it's not just the only investment, but we should, the only metric, but we should see that our investment is recouped over time. And when we're looking at that, we look at CapEx versus OpEx. Everyone's doing this capital expenditure. How much is the thing costing? How much is it costing to run the plant? And therefore, you can work out your return on investment using your operational expenditure against your capital expenditure. You will generally find, and it's so application specific, but generally speaking, if you've got quite an old system with limited sensing functionality, you will have to spend quite a bit on smart sensors. They will be awesome quality smart sensors, almost certainly Sonte ones. But once you've made that purchase and then you have optimized your plant, you can expect between 2 and 4 years to recover that cost. Once you've recovered the cost, let's say you do recover that in 2 years, year 3, then you're saving money. So there's real benefits to doing this. Wireless deployment cost advantages are phenomenal. Like I say, LoRaWAN, the ones we actually put on the wall with Velcro, not the nicest installation ever, but it was minutes. It was literally minutes to get the system up and running. So there's huge deployment cost advantages for those. And of course, because hospitals are so large and they're centrally funded as well, you can get grants for energy saving incentives as well. So a lot of hospitals are able to get centralized funds which they can then use for these retrofit applications. But of course, you need to be able to show that that grant is going to provide some benefits. So ROI becomes quite an important factor there. Like I say, example ROI periods 2 to 4 years. It's very much going to depend on your application, but within 2 to 4 years, you would expect to recover the cost of that sensing technology in a typical medical facility. In terms of the future outlook, I did promise you that I'd use AI here as an example. AI, we're looking to AI for so many things now, predictive analytics, but it seems reasonable given, how much AI we've got out there now and how it's being utilized, that AI-driven optimization is likely to be the next focus for smart sensing technologies. Embedded in the sensors itself, I would say pretty unlikely, but talking to some people who work with AI, I was quite surprised at how small a device you can actually get the models in. The machine learning you tend to need to do off-site in the cloud, but once you've built the models, you can implement those on quite limited equipment. So it seems reasonable that AI implementations will be very important and key to this field of sensor deployment. Integration with IoMT, the Internet of Medical Things, creating digital twins. If you have a digital twin, it means that you've got a sensor which exists in the real world, and then it has a sensor which is virtualized in some online environment, and that virtualized sensor can exchange data with other systems as well. So we've got lots of scope there to exchange the building data with analytical programs, with clinical programs, and to make the building and the experience of the users all one single connected experience from end to end. It's not like an office, where you walk in and it automatically sets the environment for you. But think about, how many people are in a space. So we can look at the amount of people in space and we can adapt the technology to how that system is controlled. We can do that through really simple sensing technology. We don't need people counters. We can do that through CO2. It's better with people counters, or generally better with people counters, but it can be driven by CO2 sensing. And of course, we want to think about continuous improvement, adaptive control, and future proofing as well. We don't know what's going to happen in the future, but we do know that RS485 networks are robust and they have been around for a very long time. So it seems reasonable to assume that given they're still very popular, they're not at the end of life yet. We won't see that drop off a cliff. We will see that gradually decrease in use if it goes away at all. And so, ensuring that we're using technologies which are adapted to the future is really important. Just a quick summary before we bring up the Q&A. Smart sensing is used as an enabling technology. In healthcare, we use that for sustainability. It's really important to compliance, and if you are retrofitting a hospital environment, the consideration for smart sensing, or the case for smart sensing, is really, really huge. That will allow you to have your compliance, particularly with these HTMs. It will also allow you to have compliance with the various energy directives that are required, and also to drive that carbon reduction strategy as well. In short, it's an absolute no-brainer to use smart sensing technology in these environments. So that's the end of the presentation. I hope there was something useful in there for most people. What I'm just going to do, start the Q&A on Vimeo now. We don't often get questions, but if you do have a question, and you wanted to pop that in the chat or in the Q&A on Vimeo, then please do. One thing that I would just say is, of course, this goes online. It goes on LinkedIn, or it will do at some point. If you do have any queries at all for sensors, or you want to discuss your requirements further, of course, Sonte are there to take your queries. They have salespeople who can deal with this. The geographics, so you'll probably know who your salesperson is, or you can phone Sonte directly. Someone will be able to help you. The range of Sora sensors, the Sonte LoRaWAN sensors are really good. I know they're paying me to say this, but they are great. So if you're considering this technology, you should really have a look at that. Even if it's just a test kit, I guarantee anyone who ever uses LoRaWAN for the first time, however skeptical you are, you will be amazed by it. I've been doing this for decades, and I still am amazed by LoRaWAN. It makes me feel like a magician. So there is the LoRaWAN. They also have a range of traditional smart sensors, wired smart sensors, which will work over BACnet and Modbus. I've very successfully integrated those into various different BEMS. They work extremely well too. We've got no questions coming up there, so I'm guessing that we are done for this seminar. Like I say, I hope people found it or found something interesting and useful in there. If you need anything, do contact us at Sonte. We'll be more than happy to help. Failing that, I will see you at the next webinar. I will see you at the next webinar, which is usually in 3 months. So where are we? November, December, January, February, I'm guessing. So yeah, thanks a lot. See you soon. Bye now.